This video is going to show you how to approximate the location for an image from an object that is located outside of the center of a spherical concave mirror. Since this is just an approximation, our light will not reflect off the shape of the curve, but actually off of this approximation line, which is perpendicular to the principal axis at the front of the mirror. Anytime you're doing this, you need to draw this line so you know where all the reflections will occur. First rule of the four. I'm going to draw a ray that's parallel to the principal axis and reflected through the focus. So when I draw my rays, I'm only going to draw rays from the tip of the object because the bottom of the object is sitting on the principal axis. When I draw my image, the bottom of the image will also be on the principal axis. So the only set of rays I need to draw come from the tip of the object itself. So here's the incident ray parallel to the principal axis until it touches my dotted line, not the curve of the mirror, but the dotted line. And I'll put a dot right there. And this rule says from here it goes to the focus. So I'm going to put another dot at the focus, and I'm going to draw a line that goes from the point on the mirror to the focus. That is the reflected ray. Notice that the reflected ray is extended beyond the mirror, so it's on the back side, which we call the virtual side, where the light or the photons don't belong after they bounce off the mirror, and the left side, where the photons do belong. Let's go for the next ray. This is reflected off the vertex from the tip, so it'll look something like this for the incident ray coming from the tip down to the vertex. And I'll draw a dot at the vertex. Now I need to draw a ray that's going to have the same angle as the incident ray. To do that, there's a really simple process. What I'll do is I'll measure the height of the object. You can use a ruler or just a piece of paper and get the height of the object. And then I'll slide it directly underneath the object at the same location along the principal axis. And I'll draw a dot right there. The reflected ray connects these two dots from the center of the mirror to the dot that I just drew below the object. There it is. And notice that reflected ray again extends beyond the mirror to the backside as well. So my incident angle is equal to my reflected angle by doing this. Next ray, from the object's tip through the center. So here's the object's tip, here's the center. I'll connect these two dots with a ray. And the ray, the incident ray, and the reflected rays are on top of each other. This is an approximation, and this is for a spherical mirror. So think about this as happening on the inside of a large sphere. If it's inside of a sphere, the light's going to bounce back and forth right through the center. Last ray, through the focus and reflected parallel to the principal axis. So this is the reverse of the first ray, which was parallel to the principal axis, then the focus. This is the focus, and then parallel. So I'll start with the object, the tip of the object, going through the focus until it touches the approximation line. And right there where it touches the approximation line, that's where I'll draw a line that's parallel and reflected. That's going to be my reflected ray. So at this point, your paper probably looks something like this. Notice that all of my reflected rays, those dotted lines, seem to cross at the same place on the left. Now, if you're using a ruler and you're taking care when doing this, you'll probably have the same outcome where they'll cross close to each other. If you're not using a ruler, there'll be some various errors in all this. You need to be precise when drawing your lines. The image will go from the principal axis down to where all of the reflected rays cross. So when you're showing your image, make sure you draw an arrow. Don't just put a dot where the tip of the arrow is, because I want to know what the image is doing. So you got to draw an image from the principal axis down to where all the reflected rays cross.